Then for our last case that we could come across in this section where we're doing partial fractions is where we have repeated quadratic factors. So the last section we saw distinct quadratic factors. And you probably won't see, I don't think you'll see anywhere you have two separate quadratic factors, so x squared plus 1 and then x squared minus 3 or something like that. I think most of the time it's just maybe a linear factor and then a quadratic, and then that's it. But you could also have repeated quadratic factors. So this might be something like, we'll say 5 over x times x squared plus 2 times x squared plus 4. Now, just kind of as an aside, if you had an x squared minus 2, even though that doesn't look like it doesn't look like it factors nicely, it would factor. So most of the time, it'll be an x squared plus something, which kind of makes things a little bit trickier as far as finding the a and the b and the c and so on. So for in this case, we have the a over x. We need to do a squared here. We could have eliminated one of those. We need repeated quadratics, so we need a square. All right, so then bx plus c for the x squared plus 2, and then dx plus e for x squared plus 4. Now, I don't think you'll see one with this many on the bottom, but I didn't think about. I kind of messed up as I was starting it, but that's okay. We're not solving this. We're just showing how it's set up. Now, just like with the repeated linear factors, you're going to have the first one to the first exponent and then the second one to the square. And so we have different coefficients here as we go along. So this one would probably be pretty terrible to solve if we were to do it. So we won't do it. Well, we will do example 5 from the notes. And so this one is the integral of 1 minus x plus 2x squared minus x cubed over x times x squared plus 1 squared dx. All right, so this would be a degree 5 polynomial on the bottom. We have degree 3 on top. So we would factor the bottom, but it's already completely factored. X squared plus a constant, no way to factor that as far as real numbers go. So, okay, so now we have, break this up into this form here. We have a over x plus bx plus c over x squared plus 1 plus dx plus e over x squared plus 1 squared dx. All right, so now, again, it's just the same steps that we've been doing. 1 minus x plus 2x squared minus x cubed equals, and now we need to multiply these by whatever factors are missing. So in this case, we have a times x squared plus 1 squared plus bx plus c times x times, now we're missing an x squared plus 1 there, and then plus dx plus e times x. Now, this one is a little bit trickier maybe because there's no way to get rid of the x squared plus 1. You can plug in a 0. And in fact, we probably should do that first. Let's plug in a 0. And so we get 1 on this side, and we get a on this side, and then that goes away and that goes away. So a equals 1. That's easy enough. So now let's rewrite this, what we have. So we have x squared plus 1 squared plus all the rest is unchanged. That's an x, not a times, so it's x from that denominator. X squared plus 1 plus dx plus ex. Okay, so now if this x wasn't here and if this x wasn't here, you could plug in 0 for x and then it'd get rid of the bx and you'd still have the c, but that x kind of throws a wrench in that, so we can't really do that. So maybe what I would do is let's multiply all this out and see what happens. You certainly could pick other values of x and get a system of equations, but I think this way might work out better. So FOIL this out, we get x to the fourth plus 2x squared plus 1. And carefully with this, so let's multiply x times that one. We get x cubed plus x. And then we get dx squared plus ex. Then keep going. On x plus 2x squared plus or minus x cubed equals x to the fourth plus 2x squared plus 1. We could bring these three over here if we wanted to. Well, wait a minute. Let's FOIL this one out. We get bx to the fourth plus bx squared plus cx cubed plus cx plus dx squared plus ex. Now we'll bring these constant terms over, so we get negative x to the fourth minus x cubed. 2x squared cancels. We got the minus x, and then the ones cancel. So that's all we got over on this side. Now let's group our terms, the rest of our terms, by whatever x is. So we only have one term with x to the fourth. So we have bx to the fourth plus, now what do we have with x cubed? We just have cx cubed. What do we have with x squared? We have bx squared and dx squared. So let's write b plus dx squared. And then what do we have with x? We have c plus ex, and then we have no constant term. The constant terms are completely gone. All right, so now, so this one actually works out fairly easily. So we have b, the x to the fourth term equals the x to the fourth term. So that's easy enough. So b equals -1. X cubed term equals the x cubed term. So c equals -1. And now we have b plus d would equal 0 because there's no x squared term over here. So b plus d equals 0. We know that b is -1. So d equals 1. We'll circle all these so we have them easy to see. And then c plus e is going to equal -1. -1. C is -1. And so we get that e is 0. All right. So that way worked out pretty well. So now let's fill in our a, b, and c. So we're going back up here. We're going to fill in our a, b, c. So we have the integral. A is 1, so that's 1 over x. B is -1. C is -1. So we'll factor out that negative, and we have x plus 1 over x squared plus 1. D is 1 and E is 0, so that's just going to be an x there. So plus x over x squared plus 1 squared dx. All right, now should be able to integrate this pretty well. 1 over x, of course, is the ln of absolute value of x. Now, this x plus 1 over x squared plus 1, we're going to separate that out like we did in the last problem. So x squared, or x over x squared plus 1, and then minus 1 over x squared plus 1. And then this one, we can do substitution with this. So we can let u equal x squared plus 1, and then du is 2x dx. We only have an x dx, so let's write this as 1/2 du equals x dx. So this will be the integral of 1/2 and then x squared, so u squared. So 1 over 2u squared du. Okay. So we have ln of absolute value of x. And I guess we could do a u substitution here as well. So let's, for this one, we have w equals x squared plus 1, dw equals 2x dx. So this would be the integral of 1 over 2u. So this will be 1/2 ln x squared plus 1. All right, minus this one. Now this is just arctangent of x. That one pretty straightforward. And then this one, this will turn into actually a minus 1 over 2u, which is x squared plus 1 plus c. And there we go. All right. Now, when you're doing this, I would recommend probably not like integrating. I would recommend integrating in terms of u or w, whatever variable you're using for your substitution. Do the full integration and then substitute back. I combine these steps, but I also don't have the answer right here that I can refer to just in case I mess up. But when you're doing this, probably try not to skip steps because, again, there are many places to make mistakes, and you want to minimize the chances that you're going to make a mistake. So, so a lot in this section. 4 videos, 4 different types of problems that really kind of follow the same process. They get more complicated depending on how many and what kind of factors you have in the denominator. But if you can do all of these, in a row. You don't need to master one of them first. I think probably just hit them all and go, bounce between each type. And if you have questions, you can let me know.